limits. So say we have a function which we're going to graph here, a Cartesian plot x, y, and say it looks something like this. Then if we pick a point or a ordinate a, as x tends to a, so x gets closer and closer to a, whether it be that way or that way, then what is y going to get closer to? So if we have a look at this, for this particular function, y is tending to infinity. But what if we had to do this without a graph? How would we work this out? Or how would we write this down mathematically? So to do this we use limits. And to write this down we would say that the limit as x tends to a of f of x is equal to the limit L, or in this case it'd been infinity. So the formal definition of a limit says that for a function f of x, we have the limit f of x as x tends to a equals L if for all epsilon greater than 0 there exists delta greater than 0 such that the argument of f of x minus L is less than epsilon whenever the argument of x minus a is greater than 0 and less than delta. So if we have a look at what this looks like, we can take the graph x, y, and we've got our function. Let's have something like this again. This is our function f of x. This point, we're going to take this point here as a, and the corresponding y ordinate is going to be our limit L. So if we take this point, which is going to be a plus delta, and we can have a minus delta, where delta is a small value, then the corresponding y ordinates are going to be L minus epsilon and L plus epsilon. So what we're showing is that as long as the distance between a and epsilon and a plus epsilon are sufficiently small, and L and L plus epsilon and L minus epsilon are sufficiently small, then the limit of f of x as x tends to a is equal to L. So let's have a look at an example. If we take the limit of 4x minus 1 as x tends to 3. So what are we looking at here? So we can look at this graphically. The graph 4x minus 1 looks something like this. And as x tends to 3, we can see what value y will tend to, or the function will tend to. So here we can say that that is equal to 4 lots of 3 minus 1, which is equal to 11. And we could do this for any function and any point that x is getting closer to. There are two different types of limits that we could have. We could either have, or throw you any, the whole limits which we've shown at the minute. We could have right-handed limits and left-handed limits. So a right-handed limit, confusingly on the left side of the page, would be in the form limit as x tends to a positive f of x equals L. So what we're saying here is that from the right hand side we're getting closer to a. As you can probably guess, the left-handed limit is x tends to a negative f of x equals L. So L just being the limit. So we can show these on, well, with an example. So say we have tan x. We all know the shape of tan x is asymptotic. Okay. So if we take this point here, the asymptote, which is pi by 2, then the limit as x tends to pi by 2 positive of tan x is negative infinity. So as x is getting closer and closer to pi by 2, y, or f of x, is tending to negative infinity. As we approach from the left hand side, so this way, the limit x tends to pi by 2 negative tan x is equal to infinity, because it's getting larger and larger. If the positive and negative limits are not equal, as they are here, so we've got negative infinity and infinity, then the function f of x is not continuous. If the right and left limits are the same, then f of x is a continuous function. Okay, so let's have a look at some of the different laws we can use with limits. The first, quite a basic one, would be that the limit as x tends to a of c, where c is a constant, is equal to c, because there is no coefficient of x in our function here, so it's just going to be the constant. If we have the limit x tends to a of x, then that is going to tend, or that's going to be a. So as x gets closer and closer, and this would be the function y equals x, then x is going to a, y is also going to a. Now, if we have a look at add-in limits. So if we have two different limits here, so x tends to a of a function f of x, and we want to add it to limit as x tends to a of g of x. As long as both the limits are tending to the same point, then we can say that that is the same as x tends to a of f of x plus g of x. And we can do the same thing with subtraction and multiplication as well. So the limit as x tends to a of f of x times y, the limit as x tends to a of g of x, will be equal to the limit as x tends to a of f of x g of x. And that will work the same for division, but the only difference with division is that the limit as x tends to a of g of x does not equal to 0, where g of x is the denominator in the fraction. Okay, so the one final thing we're going to look at is indices. So if we have the limit of f of x to the n, then we can take this to the power of n out, and that will give us limit to the f of x all to the power of n. Okay, so I think that's all of the main rules with limits, and just a basic introduction of them. Hope it's been useful. Thanks.